Hey everybody, I had a question that came in from Unit 7. This is section 7.3, question 4. And in particular, students usually have a hard time with coming up with that compact form in the last part of the question. So that's really where we're going to spend some time today. If you find yourself having a hard time with that, it's really a trial and error. You start putting pieces together and testing it out to see if you can replicate the terms that we get above. So that's what we're going to try out today. Here they're asking us to find the first 5 non-zero terms. So we're going to skip terms that are zero and not plug them into the answer here. For the Taylor series of f of x equals 1 over x squared, and we're centering it around x equals 1. So I'm going to start by finding the derivatives of f of x, and then I'm going to plug that 1 in to each of them. So our first function is f of x itself, and I'm going to write it with a negative exponent. Makes it a little easier for me to do that power rule without making any mistakes. So first derivative, not to be mixed up with integration, because we've been doing a lot of integration in this class. I'm going to throw the negative 2 out front and then decrease the exponent by 1. And then I'm just going to keep doing that. So now the negative 3 gets multiplied out front to give me positive 6, x to the negative 4th. And then for the next one, negative 4 times 6 gives me negative 24, x to the negative 5th. And I need 5 of these, so I've got to keep going because I only have 4 functions. And when we start getting to these higher derivatives, if you're not too clear on the notation, sometimes you'll see a Roman numeral after we get to past the third derivative. So you might see an IV for the Roman numeral 4, or a more modern, more common one you'll see these days is just written like it was an exponent, only in parentheses I put the 4 up in front there. So that would be the notation for the fourth derivative of x. And then that's going to be 120 x to the negative 6th. Okay, so I have 5 functions there, and just at a glance, if I plug 1 into these, none of them are going to give me 0, so I don't really have to go any further than this. So I'm going to start plugging in 1. So if I plug in 1 to f of x, I get just 1 over 1 squared. F prime of 1 is going to be negative 2. F double prime of 1 is going to be 6. And then negative 24. And the fourth derivative would be the 120. Okay, so sometimes I see students plug this in and say those are my terms, but this is only a piece of that Taylor series formula. If you look at that formula, we should be taking this number, these numbers here, dividing by the factorial, and then multiplying by x minus 1 here because it's centered at 1 to a power. So my function f of x is approximated at 1 over 0 factorial times x minus 1 to the 0. That'd be my first term if I'm using that definition of a Taylor series. The next one is going to be minus 2 over 1 factorial times x minus 1 to the first, plus 6 over 2 factorial times x minus 1 squared, minus 24 over 3 factorial times x minus 1 cubed, plus 120 over 4 factorial times x minus 1 to the fourth. And then I'm just going to do a dot, dot, dot to indicate that this goes on forever. Okay, so for my final answer, as I'll clean this up a bit, this first one is just going to be 1. 2 divided by 1 factorial is minus 2 times x minus 1. 6 over 2 factorial is 3 times x minus 1 squared. And then I'm going to have to start getting on my calculator after a bit, but the next one is going to be minus 4 times x minus 1 to the third, and then plus 5 times x minus 1 to the fourth. Okay, So that wasn't too bad, but we were able to kind of piece together that Taylor series, and we've got the first 5 non-zero terms here. So that answers the first part of the question. Now, to get the compact version can be a little bit more challenging, and it's really going to go on a case-by-case basis on where you want to look to find that pattern. Sometimes I want to look all the way back at the original derivatives to identify a pattern. Sometimes I'll want to look at the derivatives evaluated at the x value to identify the patterns. Sometimes I need to look here. This is why I write all these steps out, because I'm never quite sure until I get to the end of where the pattern is going to be the easiest to identify. With this one, it turns out that the very last step, the simplified version, is really the easiest place to see a clear pattern. If I take a look at this, and I kind of just look at the different parts. So for instance, if I look at the x minus 1s, they are all just going up by a power each time. If I look at those exponents, first one's 0, and then it's 1, 2, 3, 4. Okay, so that's definitely going to be part of my function. And so when I start writing this in the compact form, and they told me that n starts at 1, okay, because that's what the fill in the blank already has there, so I don't get to choose that part. So I know that in here, I'm going to have an x minus 1 to a power. So I'll start with something like that, just an x minus 1 to the n. And then if I look at the coefficients, well, they just go up just 1, 2, 3, 4, 5. Okay, so I know there's just going to be some kind of n term for that. And then the sign is alternating. It's going plus, minus, plus, minus. So I know there's going to be an alternating piece that looks something like this. Okay, so I've kind of identified all the major elements of it. Now I just have to make sure that when I start plugging in values starting at n equals 1, that I get the actual terms that are here. So I'm going to test it out. And then if it's not quite right, I start tweaking it so that it does match this. And then when I'm done tweaking it, I'll have my compact form. So let's say I just keep it the way it was written. And I start plugging in values. We're just going to test it out here. So that if I start at n equals 1, then I would have a negative 1 times 1 times x minus 1 to the first power. So already I know that something's off because that did not match my first term, which is just 1. So I need to make some tweaks here. First of all, my first term should be positive. So I need to make an adjustment to this. So I might do an n plus 1 or an n minus 1 on the exponent there. And then that will cause, now when I plug in n equals 1, I get negative 1 squared, which makes this term positive. Okay, so I fixed that issue. The n looks okay because it's just 1. But the x minus 1 is to the first power, and I need it to be to the 0 power for that first term. So I really need to be able to subtract 1 from that exponent to make that a 0 power to match my first term. So I'm going to make an adjustment to the exponent on my x minus 1 so that it's n minus 1. And now when I simplify this, I get 1 times x minus 1 to the 0, which is just 1. And I'm feeling pretty good about this. If you want to really be diligent, you can do a second term. So let's say I plug in, so this was n equals 1. So let's plug in n equals 2, the next term I would get, and make sure that that matches my second term, which is negative 2 times x minus 1. Okay, so this is going to give me a negative 1 to the third power now, times 2 times x minus 1 to the 2 minus 1. So that simplifies to negative 2 times x minus 1 to the first, which matches my second term perfectly. Okay, so I'm feeling really good about this. I've got my compact form right there, in addition to my terms right there. So I hope that help you to understand the process, the thought process that goes into coming up with that compact term. And really, this is something that just gets a little bit easier with practice. So keep up that hard work and practice this some more until you start to feel comfortable with the process.